So in today's video, we're going to be looking at working out the area under a curve. So in this little graph I've drawn here, what we can see is that if you want to work out the area under a curve, then actually we just need to integrate it, and it will be between those limits. So for example, if you see from my diagram here, what I've done is if we want to work out the area in between A and B, for example, we just need to integrate and then put in our limit. And that's what we'll go through today. So for our first question, we want to find the area of the finite region between the curve with equation y equals 20 minus x squared and the x-axis. So what it wants us to do is pretty much find the area under the curve between the two intervals when it touches the x-axis. To do that, we need to figure out what are the intercepts, okay? What are the x-intercepts? When does it cross the x-axis? So to work that out, you can work that out like normal. So let's say we have this. Well, I'm going to turn this. I'll make my x squared positive. So if I multiply everything by -1, we would get an x squared. We would get a positive x, and we get a minus 20. Okay. And if we solve this, we know that it will be a 5 and a 4. It will be an x plus 5 and then an x minus 4. So therefore, we know that x is minus 5 and x is 4. Now, what does it mean? That means that this equation, it crosses the x-axis at 4 and at minus 5. So if we were to draw a graph, okay, therefore, what does that mean? Well, that means that because originally the equation was a minus x squared, okay, we know it's going to have that N shape. So it looks something like this, okay? Mind my drawing. And we know that it's going to cross at these 2 points here. So this would be minus 5 and this would be 4. And what the question is asking us to do is we're going to work out the area under the curve. So the area under the curve would be this. This here, that is the area under the curve. We need to work that out. So now what we can do is we can use integration to work that out. So with integration, it would be the interval of the 20 minus x squared. And now we have limits. So the limits would be between 4 and minus 5. And that's all we need to do. So now we know that it crosses the x-axis at 4 and minus 5. We can just integrate and put in our limits. So if we integrate this, what do we get? Well, we would get a 20x minus x squared over 2 minus x to the power of 3 over 3, okay? And then we can now just put in our limits of 4 and minus 5. So let's start with the 4. So with the 4, 20 times 4, that is 80. And then we get a minus x squared, so that's a minus 4 squared over 2, so that will give us a minus 16 over 2, that's an 8. And then we have a minus 4 cubed, that is a 64 over 3, so that'll just be a minus 64 over 3. And then it's all of that minus the same thing, but now we put in minus 5. So this one will be 20 times minus 5, which is minus 100. A minus 5 squared over 2, so that'll give us a minus 5 squared as positive 25 minus 25 over 2. And then we get a positive 125 over 3. Just make sure you take care of your signs there. So now if you used to work all this out, put this onto a calculator, you would get a grand total of 243 over 2. And then that would be your answer. So the area under the curve, it would be 243 over 2. So for this question, we have a finite region R. It is bounded by the x-axis and the curve of equation y equals minus x squared plus 2x plus 3. We are told that the curve meets the x-axis at the points A and B. We need to find the coordinates of point A and point B, and then find the area of the region R. So for this question, if we know that it crosses the x-axis, we can just make that equation equal to 0. Now I'm going to times everything by -1 because it'll be easier to solve. If I times the equation by -1, we get x squared minus 2x minus 3, and then that will be equal to 0. Therefore, what are my two values? We will get x minus 3, and we will get x plus 1 equal to 0, and therefore we will get x as 3 and x as minus 1. So you know that it crosses the x-axis at minus 1 and when x is 3. So that a would be minus 1, 0, the b would be 3, 0. And if we know that, then we can find the area of the region under, because we know that if we integrate it with those limits, it will give us our region. So therefore, we know that the interval of 3 and minus 1 of the minus x squared, we're going back to the original equation now, and then so minus x squared plus 2x plus 3. If we was to integrate this with respect to x, with those limits of 3 and minus 1, it will give us the area under the curve which we are looking for. So let's integrate this. So if we integrate this, what do we get? Well, we'd get a minus x to the power 3 over 3 plus a 2x squared over 2 plus a 3x, okay? And then that will be our limits of 3 and minus 1. Now if I simplify this down quickly, we get a minus x to the power 3 over 3 plus x squared plus 3x, okay? And now we are going to put in our limits of 3 and minus 1. So if we go and do that now, what do we get? Well, with that 3, it will become a minus 3 cubed, that's minus 27 over 3, so that would be a minus 9, plus a 3 squared, that is a 9, and then a 3 times a 3 is again a 9, and that is minus, a minus 1 all cubed is a minus 1, then we've got that times by that minus 1, so it becomes a positive 1 over 3. A minus 1 squared is positive 1, and a 3 times minus 1 is a minus 3. And if you work all that out, what do we get? Well, we get a 9 over here minus a 1 over 3 minus 2. 1 over 3 minus 2, if you used to work that out, you would get a minus 5 over 3. So therefore, we just have a 9 plus a 5 over 3, which therefore becomes a 27 over 3 plus 5 over 3, which therefore equals 32 over 3. Yeah, and last question of the day, we have this graph here, y equals x squared, and then times by 2 minus x. We're told the region R is shown shaded, and it is bound by the c and the x-axis. Use calculus to find the exact area of R. So this question, they've actually already given us our limits. It's just 0 and 2 from looking at the graph. But if you didn't know that, you could just work that out by working out when it crosses the x-axis. You'd still get 0 and 2. But we've been given that, so we know that for this equation, it will be the integral of 2 and 0 of that x squared 2 minus x, okay? So to work this one out, first things first, what we're going to do is we are going to expand the brackets first. If we expand the brackets first, then what do we get? So we still get the 2, 0 here. If we expand the brackets first, then we get a x squared times 2, which is a 2x squared minus a x to the power of 3. Now, you expand the brackets first, it makes it a lot easier now to work out. So if we integrate these two, we get a 2x to the power of 3 over 3 minus x to the 4 over 4. And then we just need to put in our limits of 2 and 0. And if we work this out, we would get a 2 times a 2 to the power of 3. 2 to the power of 3 is 8. So it will be 2 times 8. That will give us a 16 over 3 minus a 2 to the power of 4. That is 16 over 4. So that'll just be a 4. And then on this side, well, we'd get 0 for both those values if we put 0 in. So yeah, it's just 0. Therefore, all we need to do is work out 16 over 3 minus 4. So 16 over 3 minus 12 over 3. That will just give us a 4 over 3. Okay, and that will be it for this video. We have worked out the area under the curve in this lesson. If you want to watch my previous lesson where we go over the basics of integration, feel free to watch that. I'll leave like a video link somewhere in this on the screen now. But yeah, I hope you enjoyed this video, and I will see you on the next.